Okay, this problem asks us to find all x for which f of x is equal to g of x. And they give f of x as being this and g of x as being this. And we're supposed to make them equal to each other. We want them to be equal to each other, and we want to find out for all x for which that is true. Okay, I don't have a problem with that. Let's set them equal to each other. And now let's solve this. Essentially, we are in chapter 6 again. This is a rational equation, and the best move here is to clear fractions. And so you want to multiply both sides by the least common denominator, something that will rid the equation of fractions. As you can see, it's very visual. On the left hand side, what's going to happen is these 6's are going to cancel, and I'm going to have x multiplying into both of these terms, giving me 15x minus 2x squared. On the right hand side, the x's are going to cancel, and I'm left with 3 times 6 or 18. Now, as you can see, the reason why this problem is given in chapter 8 as opposed to chapter 6 is because it's a quadratic in nature, and you need the formula or completing the square skills to solve it at this point. What I'm going to do is get it into the proper form by rearranging, subtracting 18 from both sides, and there you go. Now I'm going to use the quadratic formula here, and the best way to do this is to come to the side and write down your a, b, and c, and don't even look back at this thing. My a is going to be negative 2, my b is going to be positive 15, and my c is going to be negative 18. So now all I do is plug these values into the formula, which looks like this. X is equal to negative b plus or minus b squared minus 4 times ac. A is negative 2, and c is negative 18. And all of that is over 2a, or 2 times negative 2. So notice my use of parentheses to practice safe math when I substitute in negative values. Now, we continue on with this problem, and I need some more space. What we want to do here is simplify a little bit at a time. We're in no hurry. We want to get the answer right. I can do the 15 squared. It's 225, but since I've already done this problem, I want to show you sort of a neat repercussion here. When you do this multiplication, 4 times negative 8 times negative 18, the result of that is 144. And so what you have is minus 144. But 144 is really 12 squared. And I'm doing that to show you that basically we have the difference of 2 squares in the top of this fraction. Down below we have 2 times negative 2 or negative 4. Now, the difference of 2 squares, you know that that can crack. That 15 squared minus 12 squared is the same as 15 minus 12 times 15 plus 12. And 15 minus 12 is 3. 15 plus 12 is 27. And 3 times 27 is 81. So this whole thing here, underneath the radical, evaluates as 81, which is a perfect square, as you know, is 9. So let me just copy that in there. Negative 15 plus or minus 9 over negative 4. And so now all we have to do is consider the two cases. There's the case where we're adding the 9, and there's the case where we are subtracting the 9. When we add the 9, we have negative 15 plus 9, which looks to me to be a negative 6 over a negative 4, which is the same as 6/4, which is the same as 3/2. There's one of my answers, a positive 3/2. In the negative case, we have a negative 15 minus 9, which is a negative 26, over a negative 4, which is the same as 26/4, which is, oh, wait a second, I had an arithmetic error there. Let's backtrack. Thanks for catching that. Negative 15 minus 9 is a negative 24. Negative 24 over negative 4, which is 24 over 4, which is 6, which is our second answer. So there you go. our two solutions. I wanted to do this problem because of this little nuance here. I know you could have grunted this out and done it your own way, but to see the difference of squares in the context of this problem was quite a surprise, and I developed it out and fleshed it out for you. Okay, I hope that helps. Good luck with the rest of Chapter 8.